you had a good lunch and interesting discussions, and fun with your mini cases. Uh, we'll take a look at that. I hope that my instructions about when you were supposed to return weren't too confusing. Uh, Somebody told me once there's something called the first rule of holes. The first rule of holes is when you're in one, stop digging. And and I violated the first rule of holes when I tried to explain all across the different time zones when you should be back. Somebody told me that 80 people in Oregon went back to bed as a result of my announcement. So those of you who are here, welcome back. Let's take a look at the mini cases. Our analysis of mini case number 1, which is the flawed products, flawed experts. Everybody had an idea of what should happen, and as a compromise, they called in the university professor who told them what to do, and they ended up with some reduction of the problem they were trying to cure, but also some other problem that wasn't there before. First of all, there was no adherence to a data-based scientific approach. There was no data at all as far as we could tell. Also, no use of a 7-step method. All of the opinions of the various people on the team began at step 4. They each had an idea of what the solution should be, but there was no step 1, defining the problem, no step 2, localizing the problem, no step 3, looking for the causes. The outside expert also seemed to have no understanding of the 7-step method or the use of data or any kind of scientific approach. So this could have been a case that I described before where the expert was an expert in one particular area of subject matter, but didn't know how what changes made here may have had influence somewhere else in the system. Probably that's what took place. Now, what would you advise this project team if you were called in to coach them or give them some suggestions on how they might proceed? In fact, now what they've got is a new project and a new problem and a new need for improvement. They've got 2 problems where they only had 1. And I guess what I would suggest to them is they start all over again, go back to step 1, redefine which now of the 2 flaws, defects they want to work on, and then begin in step 2, localizing, narrowing the problem, and get the cause of that. They may be lucky and find that the same basic set of causes are creating both product defects, but they have to start with one and trace it back to its causes. They ought also to find out, they're going to need to understand what happened, what tampering did this university professor do when he went out in the machines, what knobs did he turn, what things did he do to induce change. They could perhaps from that study learn not only what if he did anything to reduce the original problem, find out more about that, but also what he did to create the new problem. One of the ways in which the expert could be used, by the way, and this is something I would suggest for all of you if you're going to try to rely on people who have some subject matter expertise, wait to call them in until you know more about the situation. In step 2, you're narrowing the problem. You're talking not just as we talked about with regard to the mock team, you're not just talking about communications problems in general, you're talking about communicating this particular kind of information to this particular kind of group. And when you have it narrowly defined, we're trying to find out the source of this particular problem in this particular part of the system, then you can call in the experts and ask questions. Why might that happen? What are the possible causes for that very specific kind of problem? Their expertise then can be used to great advantage in identifying the possible causes, which then you have to go and verify with data. That's all step 3 information. Another thing that I would do with the experts when you call them in is ask the question why several times. Why would this particular flaw occur at that part of the process? Well, because of an imbalance between this and that. Well, why would an imbalance occur at that part of the process between this and that? Well, because of such and so on. Well, why would such and so on occur? Keep using the question why to force them to get down into some of the root causes. So the experts have expertise, but you have to know how to work with the experts to get the right kind of expertise from them. Let's look at mini case number 2. All wind up, no pitch. This project seems to have no champion among the managers, which I think is a It's a critical issue. There's no leadership. Who cares about this project? If somebody cared about it, it would not have been allowed to stand in some state of suspension for so long. Secondly, the team apparently has no direct role in implementing and standardizing the improvements. So I'd be curious to know in this particular organization, whose job is it to take the best known method and carry it on to its completion? There are some organizations that have a team of technicians that go out and study the systems, come up with recommended improvements, and then they turn them over to somebody else to implement. I don't like that model personally. I think that's a mistake. I would prefer to have the same people who go out and study the systems and find out the causes of the problems and find out the best solutions to deal with those problems, to let them keep on going, carry on through to some state of completion, and have the support and the authorization of management to go ahead with that. In fact, there ought to be on the project team, or at least on some group of managers affiliated with that project team, the people who have the authority and the clout to make those changes and have some investment in it. With this particular group, with the all wind-up, no-pitch group, there are several questions that are step one types of questions that would have helped this group. In step one of this project, if somebody had asked questions like, why is this project important? Why should we be doing this? Who cares about it? Who cares enough to see it through to its completion? Is this project important enough that other priorities won't come along and displace this one? And if there are other priorities that are going to come along and displace this project, let's take care of those priorities first, and then we'll get to this one. I also want to make a comment about the involvement of line management in improvement efforts. And not everybody agrees with me on this, but I think it's critically important that improvement efforts have direct linkage to line management. I think line management ought to be involved in identifying the improvement priorities and involved in selecting the improvement projects. And this case is an example of what goes wrong when line management has no investment in a particular improvement. My belief is that there are too many improvements that need to be undertaken, and there are too few resources for engaging in improvements to have those resources spent on improvements that managers don't care about. Maybe in our organizations we'll get to some point where the only improvements left to make are ones that are relatively inconsequential and that managers don't care about. But until we get to that point, I think we ought to have a very clear process for identifying the improvements, for prioritizing improvements, for identifying which is the next improvement effort that's waiting in line for enough resources to be applied to it. And that ought to be an ongoing process of management review and involvement. Too often managers see improvement teams as a form of abdication. They say it's a good idea, you guys go out there and improve things, and then managers go back to the same old style of management and don't let the whole total quality effort and the improvement effort change the way they manage it all. And that's the kiss of death. I think managers have to be involved from the get-go in every step of the process. And this is an example of what happens, but there's all sorts of other problems. And in fact, what we do with our client companies is to teach managers the 7-step method, both as a means by which they themselves can get involved in improvement efforts in their specific jobs, but also as a framework for asking questions. It's a wonderful way by which managers can review the work of others who are engaged in improvement efforts. For instance, one of the things that managers often do that's the wrong thing to do is when people are out there trying to make some kind of improvement, they'll ask step 5 kind of questions. What are the results? Have you gotten any results? Well, they'd be much better off to wait until the project teams are at that point in their effort to ask those kind of questions. What they ought to be asking are step 1 questions when an improvement effort is at step 1. Who cares about this project? Why is it important? How does it affect the customers? The questions that are listed on that one page where we have the 7-step method laid out and then the bulleted questions underneath it. So we use the 7-step method as a way of teaching the logic of improvement to managers so that they can take a logical approach to guiding and reviewing and encouraging improvements in their own areas. I want to move into section 5 now, and we're going to be elaborating on the 7 steps. There's a lot more that can be said about them beyond what we've done. Oh, I'm sorry. Before, can we scratch that one? There's one other point I want to make, and that was, given this this project team, this all wind up no pitch project team, what would you advise them? What would you tell them to do at this point? And it's a more difficult question, I think, than the earlier one, because the project team has in effect finished its work. I think there are larger issues, and I would try to work with this organization to get clear about the internal system for improvements and how the managers get involved with them, and how managers are attached to projects, and then whose responsibility is it to follow up on a project and make sure that it's implemented. That's where the weakness of this organization in this case study is, and more work has to be done with them. It's not coaching of the project team. The project team did its job. It's coaching the managers who are not responding to the work of the project team. Now, if we can, we'll go into section 5 and some elaboration on the 7 steps. Okay, we were just before getting ready to talk about section 5 and elaboration on the 7 steps, and I had said that I wanted to talk a little bit about PDCA. What is PDCA, or the PDCA cycle? PDCA stands for Plan, Do, Check, Act. It's a cycle of improvement that Dr. Deming taught the Japanese back in 1950 when he visited them. Dr. Deming doesn't call it the Deming cycle. The Japanese call it the Deming cycle. Dr. Deming calls it the Schuhart cycle, after Walter Schuhart, from whom he learned roughly this same kind of logic back in the 1930s at the Western Electric plant, where they both worked. It's one of those concepts that I keep running into in this quality business that seems terribly simplistic. What can be more obvious than to plan something and to do it and to check on how well you did it, and then to act or adjust based on what you learned. But it's when one visits Japan and sees how Japan organizes their improvement efforts, they have just internalized this Plan, Do, Check, Act cycle and organized around the Plan, Do, Check, Act cycle so much that it's more than a simplistic kind of framework for improvement. It's a very, very powerful way to think about improvements. And when you think about how we ordinarily think of improvements in this country, it's sort of do it, and if it doesn't work, do it again. If it doesn't work, try something else. And if it doesn't work, try something else. Very little planning, very little checking, very little adjustment of what didn't work to make it work. It's just to replace that with something else new. It's sort of the illusion of progress cycle. I have a friend, Linda Finn, another Joiner associate who travels with me a lot in my consulting work, and she has a hobby, she claims, of collecting versions of the PDCA cycle. Dr. Kano, who's one of the Japanese teachers of quality, says that in some companies PDCA seems to stand for Please Don't Change Anything, and that's his version, which Linda Finn has collected. But Linda has her own version of the PDCA cycle, which is P stands for Ponder, D is Diddle, C is Cover Your Tush when things go wrong, and A is Amnesia, forget that you ever did it. That's another PDCA cycle, but the real PDCA cycle is a very powerful approach toward planning change. Now, what's the difference between the 7-step version that we've been talking about this morning and the PDCA cycle that I'm going to mention a little bit about now? Well, for one thing, this is our way of teaching it so that the differences are a little easier to understand. PDCA is what you do when you know what you should do. When you know what the right change is, then you approach the implementation of that change using a PDCA cycle. When you don't know what the change should be, then you use the 7-step method. And this is clear in the diagram on the page that's entitled The 7 Steps and PDCA. Start with a problem. What's the problem? And then what's the solution? If you know the solution, then you go in one direction. If you don't know the solution, you go in the other direction. If you don't know the solution, then you do the 7-step method. And by the way, if you study the 7-step method carefully, you'll notice that steps 4, 5, and 6, solutions, results, standardization, are in fact the PDCA cycle. But what if you know what the solution is? What if you know what the right thing to do is? Then you ask the question, is this a simple thing to do or is it complicated? If it's a simple thing, then you can go ahead and do it. An example of a simple thing is if a 100-watt light bulb burns out, you put a new 100-watt light bulb in. That's a no-brainer. Sometimes a lot of solutions are that simple and you don't need to go through an elaborate process. Don't use unnecessary logic if it's so clear what the solution is. Though I would caution you that some solutions that appear to be simple no-brainers are in fact a little more complicated than that. An example that I learned from one company was that they were about to replace some pumps in a machine, and the pumps had deteriorated to a point where they needed to replace them. They were going to replace them with the same kind of pump, exact same model, exact same brand. Everything was the same, and then they went to replace those pumps, and they realized they'd better think about this. It wasn't a simple replacement effort because, in fact, the machinery had been adjusted over time to compensate for the reduced function, the reduced capabilities of these pumps. So as the pumps got weaker and weaker and weaker over time, other adjustments were made. Well, if the new pumps at maximum efficiency were put into that same system, which had been adjusted for a deteriorated pump, there would have been some chaos, some mess to clean up. So they were smart enough to know we'd better think about what we've done to compensate for the old pumps before we put the new pumps in. So that's an example of just going ahead and doing it could be the wrong thing to do, and you could end up not only with no improvement, but you could end up with deterioration instead. It's again another example of taking a systems view of things. So if you don't know, if you know what the solution should be, but it's not simple, then go into the PDCA cycle. Spend a lot of time planning how you're going to implement this solution, and include in your planning time how are you going to monitor it. Then you go and implement the solution on a small scale, see how it's doing, make whatever adjustments on the small scale before you broaden it to a wider scale. And then you check it, you monitor it, you see if it's accomplishing what you want it to accomplish, and then act is adjustment. You make whatever adjustments are necessary to make sure that this accomplishes what you want it to accomplish and that it stays in place. Constant PDCA cycle. We'll see some more applications of the PDCA cycle later on when we talk about standardization. I want to also talk a little bit about the 7-step method and some of the typical tools. And here I'm going to be making some reference to statistical tools that you may or may not be familiar with. But for those of you who understand some of the statistical tools, you'll see ways in which they plug into the 7-step method. And it's going to be difficult to tell you exactly which tools to use when, but there's a general framework within the 7 steps that will help you to identify them. So let me go through the 7 steps one at a time and make at least a couple comments about possible tools to use. The first step of the 7-step, remember, is project, when you're defining the project. And here, it's very useful to use things like Pareto charts to let you know where the worst problem is. You might do a Pareto chart on injuries, for instance, that tells you in this project we better work on this kind of injury because there's more frequency of that kind of injury than any of the other kind of injuries, or this kind of injury results in more lost time from work and so forth. That's a way of defining what the project should be. Also, what's important is operational definitions. An operational definition is a way of defining the thing that you're working on. For instance, one of the things lacking in the mock team project was an operational definition of what it meant what did poor communications mean. There was no definition of that, and they needed to have some definition of the phrase inability to communicate. The second step of the 7-step process is looking at the current situation, and here a lot of the statistical tools come into play. First of all, a flow chart, it's not a statistical tool, but it's an analytical tool to look at what the process is, to see the various interdependent steps in the process. Flow charts are invaluable as a way of seeing what the current situation is. Check sheets, you may have a check sheet as you're studying the process to see what kind of errors take place or what kind of flaws take place. Control charts are a way of charting statistical data over time. It's an invaluable way of seeing what kind of variation you have, what are the kind of causes of variation. Scatter diagrams can show the interaction between two different kind of characteristics. There's all sorts of various statistical tools that you use to analyze the current situation and show you what kind of patterns you have in that process that you're studying. Step 3, cause analysis. We've already talked about one tool for cause analysis, which is asking the question why 5 times. Another tool which is invaluable is the cause and effect diagram, also called the Ishikawa diagram, after Dr. Ishikawa, who developed the tool. It's also called the fishbone diagram because it resembles a fishbone when it's displayed. At any rate, it's a way of finding out what the possible causes are. I would have 2 cautions with regard to the cause and effect diagram. A mistake that I commonly see made with regard to a cause and effect diagram is that they're used too soon. They're used on a broadly defined project. Cause and effect diagrams are much more useful if they're used on a very narrowly defined project. If you have fishbone diagrams, if you've used fishbone diagrams or cause and effect diagrams and find they take up a whole wall, then it means you probably used them too soon. Spend more time narrowing the project and have a very small fishbone chart on a very tightly defined problem area. The other problem I've seen with cause and effect diagrams is that they get used not to show cause and effects, but they simply get used as an alternative way of showing an outline. If you need to show information in major categories and subcategories and sub-subcategories, use an outline. Don't use a fishbone diagram for it. Save the fishbone diagram to truly show cause and effect relationships. Under cause analysis, there's a third tool that's incredibly powerful and invaluable, and that's the designed experiment. And get your local neighborhood statistician to teach you how to do designed experiments, and you can get a lot of information that'll help you decide what the best combination of circumstances are to get an improved process, or what the combination of circumstances are that create the defect. Step 4 of the 7-step process has to do with solutions, and here most of the appropriate tools are the decision-making tools and planning tools. There are various kinds of matrices that help you take various solutions and compare them along a number of lines. For instance, if I listed a bunch of solutions, possible solutions, and asked for each one of them, which causes do they attack? Because sometimes we're dealing with several causes, and some solutions will deal with more than one cause, some will deal only with one cause. You can also ask how expensive is this solution to implement? How complicated is it? What kind of technical training does it require? There are various questions that you can ask. What are the potential problems? Some solutions may risk other kinds of side effects that you want to avoid, and how easy is it to avoid those side effects, or how easy is it to remedy them should they occur? There's a series of questions, and you'll see some examples in the team handbook and others where it shows how to take the list of solutions and then using a matrix as several columns across, ask those different questions. And it's just a tool to help you compare one solution versus another as you're trying to decide which is the best solution to implement. There's also planning tools. A planning grid is in the team handbook. Also, a Gantt chart is a way of organizing work according to a sequence of time. It's a visual way of seeing which work has to be done when. All those kinds of planning tools are useful as you're deciding how to implement a solution. With regard to step 5, let's take a look at step 5 of the 7-step model, the results step. Here the tools are very similar to the tools that you used in 1 and 2, because all you're trying to do is to compare the after data to the before data. In step 1 and 2, you gathered some data on the kind of problem that you have and the patterns of the problems. Having implemented the solutions in step 4, now you want to look in step 5 at the data that you have as a result of the solutions and contrast the data before and after to see if you've had any impact at all with your solutions, and hopefully you will have. Step 6 is standardization. We will see these tools pretty soon. One will be a deployment flow chart, and the other will be what we call a QC process chart, and then any other forms of standard operational procedures. That's what's important in standardization. With regard to future plans, here you're trying to decide where to go from here, and if you're closing down the project, then it's good to have a closure checklist, a set of things that you want to make sure to do with every project in your organization to capitalize on the learning that may have been gained in that, and to make sure that all the projects are finished well. On page 5 is a page that shows some of the links between the 7 steps and the team handbook. And I won't elaborate on these. I'll let you read through them yourselves. The 7 steps were something that we have learned about and developed after the team handbook was written and published. So the 7 steps will not be included in the team handbook, but contained in the team handbook are things that will help you do each of the 7 steps. And so page 5-5 is an attempt to show you the linkage between the 7-step method and the team handbook. Some of the tools are explained and some of the strategies for improvement that are very much part of the team handbook. So that's the elaboration on the 7 steps. And what I want to do now is pause for just a moment, and then we'll begin step 6, which is standardization. Okay, we have finished with our pause. I hope you took advantage of it to call in your questions. We're ready to begin step 6, standardization. Remember the 5 ingredients of true improvement that we talked about before. The last ingredient called for a clearly described and standardized new method. So you've gone through all the 7 steps. You know what the new method should be. Now what do you do with it to make sure that it gets used? And that's what we're talking about in section 6 when we talk about standardization. Standardization is taking the improvement and making sure that it's used by everyone. As I said before, one of the managers that I work with calls it putting it to bed. Another word for it is called institutionalizing it, making it part of the everyday routine. We want to make sure that all the different operators are using it, all the different shifts are using it. One of the sources of problems and unnecessary variation in our organizations is when a process isn't standardized. Different people do the same work in different ways, and that creates problems that are difficult to measure, difficult to understand, but it creates a built-in variation in the system. Many improvements have been lost, and a lot of good work has been wasted from the lack of standardization. So let's talk about what we mean by standardization. First of all, standardization includes, this is a summary of what's on page 3 in your notebooks. It includes 4 basic elements as far as I can tell. One of them is, first, a new standard operational procedure. And the new standard operational procedure will describe the work that's got to be done. Who does what, when, where, why, and how. And then how is it monitored? And by whom is it monitored? When, where, and why? All of that information should be part of the new standard operational procedure. Secondly, standardization includes training. If we have a new method, people have to be trained in the use of the new method. How to do this work. The standard operational procedure, if it's displayed graphically, will be of immense value in training people. But we have to train people in the new method, and then we have to train the trainers of those people in the new method. We have to make sure that the current operators in the old method are trained in the new method, and then we have to incorporate the training in the new method in the training for new employees. It's a fairly extensive effort of training that has to be undertaken. Third, error prevention and error proofing. The Japanese expression is translated foolproofing, but I would like to presume that the people are not fools. They just need to be helped to prevent the errors that even wise people can make. And these are the mechanical interventions, the changes in the system that don't allow people to make the mistakes. Sometimes instead of exhorting people to not make mistakes, we can make adjustments in the mechanics or the electronics or the paper filling forms of the system so that those mistakes are either minimized or eliminated altogether. Finally, symbolic reinforcement. I think part of standardization has to recognize that change is not a logical process, that the things that help us to change are varied. Some of them help our minds to change our ideas, and others of them just help us to change our habits. So if you can imagine, on the day that a new method is supposed to be introduced into your company or your organization, You walk into the front door and the entranceway has changed. It's been redesigned or repainted, and you walk into your work area and that's been changed in some visual way. All of which may be useful by itself without any other change, but all of which on the day that a new method is to be used helps reinforce and remind people that, oh yes, we're doing it differently starting today. So it's a sort of the kind of environmental changes that will help reinforce the fact that we're changing the way we receive orders from our customers, or we're changing the way we're doing the billing process, or we're changing the way that we manufacture this particular part of the manufacturing process. That's what I mean by symbolic reinforcement, letting people know that the new method has started and the old method is no longer around. I've even been part of one organization where the symbolic reinforcement involved a short ceremony at the beginning, at the end of the day of the old method. That is, the last day the old method was being used. At the end of the day, everybody got together and they took the old manuals, operators' manuals, and put them in a box and took them out to the parking lot and burned them as a symbolic and dramatic evidence that the old way was gone and tomorrow we're going to use a new way. They probably got in trouble for polluting the environment. Okay, now I want to talk about a tool, a standardization tool called the QC process chart. The QC process chart is actually a combination of tools. So I'll be first of all describing to you what's called a deployment flow chart, if you haven't seen this. The system that we're going to be working with here is called a spare parts system. So imagine that this organization provides spare parts for its customers. Its customers have machines that break down, and when they break down, if a part is needed, they want that part immediately. And this is the process that receives the order for a spare part and sends it out as fast as possible to the customer. So some key characteristics of this operation are the speed, this turnaround speed with which they can get those parts to the customer. Now, here's the deployment flow chart. It consists of 4 columns. There's one column marked customers, another marked customer service. These are the people in the organization that receive the call from the customer. Warehouse and shipping finds the part in stock and ships it. And then later on we'll talk about this part of the organization, product support and manufacturing. When a part's out, it's product support and manufacturing, which has to manufacture a part quickly to get it to the customer. So you'll notice that two things about a deployment flow chart. Work gets deployed across, depending on who's got the action. It starts out with a customer, and then quickly customer service has the action, passes it on to warehouse and shipping, and so forth. So the deployment flow chart shows who is doing the work by showing it underneath the column corresponding to the appropriate party who's doing the work. Time is indicated in a downward direction. Who does the work is indicated, as I just said, in a crosswise direction. So following this, the customer orders the part, customer service receives the order and processes it, sends it to warehouse and shipping, and here's a critical point here. Is the part in stock? If the part is in stock, they ship it to the customer, they take care of the paperwork to customer service, who takes care of more paperwork and sends the paperwork to the customer. Fairly simple process. Now you'll notice that some of these boxes are shaded, and those shading is what happens when a part is out of stock. This is what we call complexity. It's non-value added work. It's work that wouldn't be necessary if the parts weren't out of stock. Deming calls it scraping burnt toast. He has been quoted as saying, "Let's make toast American style. You burn, I'll scrape." So here's an example of scraping burnt toast. It's all the extra steps that are added to this process because the part is out of stock. They have to refer the out-of-stock part to process support, product support and manufacturing, who manufactures this product and so forth, and finally gets a chip. You'll notice that if we had time indicated along this line, it would extend the time that it takes for the customer to get the missing part quite a bit. Probably in most operations as much as a week or 2 or 3. So that's I wanted to show you two things in what we've looked at so far. The deployment flow chart, which shows the work flowing downward in time and flowing crosswards in terms of who's got the action. I also wanted to show you with regard to a deployment flow chart that it's possible to indicate complexity, work that would be unnecessary if the product were perfect. Future improvement efforts would be aimed at removing the shaded boxes. The ideal process has no work having to do with missing spare parts because none of them would be missing. Now let me go on to a couple other columns that will get this closer and closer to a QC process chart. This, by the way, is not, this diagram, spare parts system diagram, is not what I would call a QC process chart, but it's a chart on its way to becoming a QC process chart. You'll see what I mean by that statement in a minute. Here's a column called Standards and Key Process Indicators. What that means is you use this column to indicate key points in the process where things could go wrong or where things do go wrong. And what you want to indicate in this column is, what do we monitor? What are the things about the process? What are the characteristics of the process that will tell us that things are going well or poorly? That's what a key process indicator is. So for instance, one of the key process indicators throughout this process is timeliness. The customer wants that part yesterday. So what are the indicators that tell us that this process is moving as quickly as possible? We might find key places where we know it's a bottleneck and we want to monitor how long that part of the process takes. Because we know if it's moving along in a timely fashion there, then the whole process is going to be moving along in a timely fashion. So under key process indicators, we'd say promptness, and define promptness in terms of that spot. Like it might be in terms of hours after the order is received, as an example. We know that this is a key place where things go wrong, the out of stock. So we would indicate here, what are the indicators, what would indicate that part is not depleted in the storeroom? What are the things that we can monitor to make sure that we'll never run out of parts? Well, if it's a very complicated parts inventory system, there's a lot of things to monitor. And maybe what's necessary is to identify which parts are most likely to be asked for, and then what will indicate that the level of inventory will prevent us from being out of parts. But that's the indicator that would be shown in this column called a key process indicator or standard. Now, there's another column here called method of monitoring. That is, how do you monitor these standards or key process indicator? What kind of data do you gather, and how do you record that data? What kind of chart do you use? Now, when I'm working with a company to form a QC process chart, I start out with a deployment flow chart, just say, describe the system. And we might spend quite a bit of time describing that system. We might say, we might find out, for instance, if the different operators do a flow chart, they may have different flow charts because they each do it a different way. So it's important to have people agree that this is indeed the method that we use. And then I would ask them what goes wrong, and that will tell us where we have to start defining some indicators of the process, indicators that will say the process is going well or poorly. And then I'll say, okay, then given those are the things that you have to monitor at certain places in the process, how do you monitor them? What kind of data are you going to gather, and how are you going to record that? And then we're on our way to developing what we call a QC process chart. In that chart, you saw the beginnings of a PDCA system. That is, the P isn't there because it's the planning that creates the chart in the first place, but it describes the doing, the D part of the PDCA cycle. It describes how the work gets done. It also describes how the work gets checked. The last two columns have to do with the C part of the PDCA cycle. So it includes the methods of monitoring. Let me say a little bit about key process indicators. In manufacturing processes, the key process indicators have a lot to do with the nature of the production process itself. A key process indicator might be temperature or pressure or pH levels or some of those things. And you could, if you sat down to come up with key process indicators for every step in the process, you'd drive yourself crazy. I urge you, start with the areas where you're having trouble. Don't try to do them on everything. Do them where you're suffering some pain. In administrative processes, usually the key indicators have to do with timeliness, accuracy, and thoroughness. If you have to process some paperwork, are all of the items entered in that form accurate? Is the form filled out thoroughly? And is the form processed in a timely manner? Those three indicators of the process will cover most administrative areas, and then you can look through the flow chart, the deployment flow chart, and say where are the spots where we're likely to lose time, or where are the spots where information is going to be missed or entered inaccurately. Now I want to draw your attention to page 9 in section 6. And here we have what I would call a QC process chart. This is much closer to a QC process chart, and this is in fact a kind of boilerplate, a blank form. I've had companies take out some of the printing that's there in the columns down below and then use this as a form, in fact, for doing a QC process chart. Let me describe this one section at a time. The first couple blocks refer to the doing of the work. And you'll notice it starts with a deployment flowchart, very similar to what we showed. And if your deployment flowchart has a lot of columns because there's a lot of players in this process, then you're probably suffering from over-ambition. If you have a narrowed process, if you have a very small operation, the deployment might only involve 2 or 3 people, and in fact some deployment flowcharts involve only 1 person. Let's look at the next column that's in that same graphic, operating standards. That column is there to allow you to elaborate on certain steps in the process. So you've described the process as it flows in the deployment flowchart, and then every once in a while you may want to give a little bit more detail on the method for performing a particular task. Let me give you an example. I saw one on it had to do with a process for recording the serial number of the product. In this case it was an automobile, and some forms had to be filled out that included the model or the vehicle number, the registration number for this particular car. And in the QC process chart, it said, here's where you'll find the vehicle number on the car. There's usually a little plate up near the windshield, and there's another plate under the hood of the car. And so it said very specifically, look for the number there, and then here's on the form, here's the place where it gets listed. So you can, in this column called operating standards, you can either give the specific instructions, but that's not much room. Sometimes you can fit them in a column as small as that, or make reference to some other document where the specific instructions are. Let me give you another example. I was working with one group of people, and the process they were talking about was a labeling process. They had to take cartons into which product would be placed, put a label on the carton, fill it with the product, send it on its way. Well, a critical step in that process was to make sure they had the right label on the product, on the carton. There was a shelf full of labels, and then there was the order number. And they had to take the order number and they had to take the order form, look at the order form, find the product number, take the right label off the shelf corresponding to that product number. So the instructions here said, here's where you check the order form for the number, and here's where you look on the shelf to see where that label should be, and make sure, don't take it for granted that the labels on the shelf are in the right place. Check the label to make sure it's the right label for the carton. It's a simple thing, but it says very clearly how you do that one step in the process. At another step in the process, a critical part of that process had to do with the gluing operation, because you take these labels and stack them in a machine, and then the machine glues the labels on the cartons as they go through. And a critical parameter there is that the glue pot, the pot of glue in this machine, has to be full. So in the operating standard, it says, here's what we mean by a full pot of glue. There's a little line in there that you'll look at. It sounds like it's too much instruction, but in fact, if you're going to use this for a number of purposes, among them training new employees, you need to have that much detail. The glue had to be at a certain temperature, so so adjusting the temperature knob was part of this process, and it said that at that point in the process as the deployment flowchart showed the work unfolding. Let's go to the column, the next three columns now. The first three columns talked about the doing of the work. The next three columns talk about the checking of the work. This is the C part of the PDCA cycle. First, we talk about control items. What's the key indicator? When we looked at the spare parts system, we talked about the key process indicator. That's what goes in here. With the labeling operation, one of the key control items was the temperature of the glue. So what would be written in that column is the temperature of the glue, corresponding to the step in the process where that has to be checked. And usually it just simply describes the factor, the indicator itself. It doesn't say much more than that. The next column, called the monitoring method, and that label may be a little misreading, so pay attention to both the written definitions and what I say about it. The monitoring method describes the standard of measurement. So for instance, in the temperature of the glue key indicator, the monitoring method will describe what temperature it should be, or the range of temperatures which is okay. The glue must be between X degrees Fahrenheit and Y degrees Fahrenheit. So the first column, control item, says here's the indicator. The second column says here's where the indicator should be. If the key indicator in an administrative process is timeliness, the first indicator, the control item column, will say timeliness, and the second column will say here's where this particular item ought to be relative to some starting point in time. No more than 4 hours past the time of receipt, or 3 days, or whatever the appropriate standard for timeliness should be at that point. The third column says management method. And by this we don't mean what managers do. That may be confusing also, but management method here refers to the way the data is managed. So as you monitor the control item to make sure that it stays within the parameters of the monitoring method, you take data. And therefore the management method says, what form do you take that data in? Do you take the data in the form of a run chart, a control chart, a scatter plot? Which tool do you use? So this is about all the information you need regarding the monitoring of the process of work. The one set tells you here's how you do the work, and then this set of instructions says here's what you monitor, and what you're looking for as you monitor, and how you record the data that you observe as you monitor that particular indicator, looking for these particular characteristics. With regard to thoroughness, for instance, let's say it's an administrative process, some admissions process, and you're trying to make sure that all of the necessary information is included on the admissions form. Well, sometimes these things are a little jumbled. So that if I'm an admissions operator taking people into some kind of a process, say a hospital admissions operator, what's critical is that all the information is filled out. What's also probably critical is that it's done in a relatively timely fashion. But let's say that's the thoroughness and accuracy that's important. Well, at a critical point, you can say thoroughness for the control item. Now, how do you monitor that? How do you watch that? Well, it could be a checklist. It could be a checklist that the admissions clerk uses to make sure that all of the items were covered in the list. And that's the monitoring method. And the management method is maybe gathering data on his or her own process. What are the things that I usually miss? That would be an example of that. I've noticed here in the studio where this broadcast is coming from, on each of the cameras is a checklist of the things that each camera person has to be sure to do in getting ready for the broadcast. that helps them to make sure that they don't miss any adjustments or parts of the operation. I noticed that. I'm glad to see that George Washington University is practicing some of these things. Let's move to the third set of columns. The third set of columns refers to the response to the results. The first is, what do you do with the mess that you got? The procedure for the defective output. What do you do with the results of the flawed process? The operators need to know what to do with that. And then the second is, what kind of adjustments do you make to the process? And then the third is, what deeper improvements to the system need to be anticipated? Let me talk a little bit about this. There's a concept that I am finding more and more useful, and it has to do with what we call the levels of fix. Let me use a simple process to show what I mean by this. Let's say you're making toast for breakfast in the morning and you burn the toast. What do? Well, one thing you have to do is you have to decide what to do with the toast that you've got that's burnt. Do you scrape it? Do you feed it to the dog? How do you clean up that mess? And also, what do you do to the toaster to make sure that the next bread that you put in there doesn't get burnt the same way the one got burnt that you have? That's the first level of fix, and that corresponds to the column called the procedure for the defective output. Most improvements in our organizations are the equivalent of a first level of fix. Sometimes we're proud if we can take care of the first level of fix. Let me give you an example of the first level of fix. A certain airline was reported in the newspaper. I won't tell you their name, but their headquarters are in Minneapolis, and they're called Northwest. They also have a place in Detroit that they fly in and out of. The story in the newspaper was that they were having so much problem with irate customers that what they did was take their counter personnel and put them through a course in how to deal with irate customers. That's at best a first level of fix. That's scraping burnt toast and not much more. So when you have a problem, you have to deal with the customers who are upset. In the spare parts system, you have to deal with the customers who aren't going to get their parts as fast as they want because it's out of stock. And then you have to scramble to make a new part so you can send it to them. Those are all first levels of fix. But second levels of fix require something else. The second level of fix requires more data so you understand the patterns of this operation better. You don't buy a new toaster. You don't buy a new spare parts system. You keep the same one you have, but you learn more about it so that you can avoid problems. It's a more preventative step. For instance, going back to the toaster example, an example of a second level fix in the toasting operation would be to start taking data so that you know if you have this particular kind of bread, you know what adjustment needs to be made to the toaster. Or if it's dry, if it's a couple of days old and drier and more liable to burn, you know what adjustments to make to the toaster. Or if the weather conditions are very moist and humid, you know what adjustments to make to the toaster. So you know so much about the bread and the interaction between the bread and the toaster that you know always what kind of adjustments to make so you never burn toast. That takes a whole lot more logic and data and discipline to make those kinds of adjustments to the system. That's what we would call a level 2 fix, and that's what's meant by that middle column called the procedure for process adjustment. I call them there a temporary fix of the work process, and that may be unfair, implicitly negative. Sometimes the level 2 fix is plenty of fix for some processes. In many companies that I have seen, I'd be satisfied if they had level 2 fixes in place. Level 3 fix is deeper still. By the way, I hope you've noticed that these are related to the questions why. These all have to do with why does that happen. Level 3 fix in the toaster example might be, let's have a whole new toasting system that senses the kind of weather conditions and the item being put in the toaster and takes care of it without adjustment. So we don't need to make the constant adjustments. The toaster takes care of that itself. Or another example of level 3 fix is, let's figure out something else to have for breakfast. It's eliminating the problem at a deeper level. That may sound silly. You may, as a business, you can say we can't afford to convince our customers to change their appetites. But in fact, did you know that Toyota doesn't make a green car? Toyota doesn't make a green car because they don't believe that they can put a finish using the pigments that are involved in a green paint. They can't make a finish that they believe is satisfactory to their standards with a green car. So they just sort of say to people, you can have any color you want except green. Ford used to say you can have every color you want as long as it's black. But then as we learn the technology of offering things, we learn to do it. We don't promise customers things that we can't deliver. That's another part of that level of fix. Understanding what the capabilities of our processes are. So, the ACT columns talk about what do you do in response to problems and how do you accomplish deeper levels of fix. One of the things that's necessary in that last column, the procedures for system improvements, usually what this involves. And think of this as the operator on the floor. The operator on the floor has to know what to do with the mess that's been created by a flawed process. The operator on the floor has to know what kind of adjustments to make and learn how to monitor the system better to avoid them. But what does the operator on the floor do with the level 3 fixes? Well, the level 3 fixes usually mean what kind of data has to be gathered in what form and sent to whom, who in management, who owns these processes and can change those systems at a basic level. So if I'm a manager, I have to have information to know whether I'm going to do a level 3 fix in the process. And so I make sure that I get that kind of data in a reliable way. In the labeling process, when the labeling process broke down, they have to bring in people to do the labels manually if the machine isn't operating correctly. Well, what they've determined is that they want to let management know how often they have to bring in extra help to manually do the labeling. That's an indicator of the inadequacy of the current system, and that data may help managers decide whether they need to think in terms of a new labeling system. So you shouldn't go to level 3 fixes until you make sure that you've gone as far as you can in the level 2 fixes. So I want you to now just step back and look at this whole chart, this QC process chart. It's a method for describing in great detail how the work gets done, in great detail how the work gets monitored at the key points that need to be monitored, and in great detail it says, here's what you do in response to various kinds of problems. And this QC process chart can be used to help standardize the system, to make sure everybody's doing it the right way. It can also be used to help people understand when things go wrong. You can use the QC process chart to say, did we not do something that's on the QC process chart? Did we miss a step? Or if we did all the steps, then we're missing something on the QC process chart. It can be used as a sort of a master plan to do some problem solving and troubleshooting. When I ask people, is everybody in the shift or everybody in this operation doing the work the same way? They'll start out saying yes, but then if I ask them to put that down in this form in a QC process chart, they'll soon find out they aren't doing it the same way. They aren't doing the work the same way. They aren't responding to problems in the same way. They don't have any standardized way of doing the work. So the building, starting with a deployment flowchart, the building of a QC process chart is a wonderful way to involve people in the standardizing of their own processes. I can't say enough for this approach to standardizing work. And this, by the way, is what our competition is doing. The people who are beating the socks off of us in the marketplace are paying attention to this kind of detail when they're describing the way of doing work. And so that when we talk about improvements, we're talking about something very much more exacting than what we currently do with improvements. Improvements ought to end with this. And when you have this and it's in place, then you know that improvement, that new best method is locked in. So that's my sermon on QC process charts and standardization. But before we leave the subject of standardization, I want to talk a little bit about variations in the deployment flowchart. Remember, deployment flowcharts are useful all by themselves. If you don't go much past it, you can make a lot of difference in your processes if you get all the people together and say, let's do a deployment flowchart on this process to make sure that we know what the method is. And invariably, I have found that people find out they're not doing it the same way, and the construction of a flowchart will show them that they're not doing it the same way. And then if they can agree to do it the same way, then most of the battle is won. On the top of page 611, you'll see one variation of a deployment flowchart. Time goes down in sequence the same way as the other deployment flowcharts, but you just put a little different information in the boxes as it goes downwards, and you have an additional column that may explain why you do it that way or how. Let me make a comment about that. It's not enough sometimes to tell people to do it in a particular way. It's important to tell them why, particularly if the reason why it ought to be done that way isn't clear. I had some of our people from Joint Associates went to Japan recently, and here's what they noticed with regard to standardization. They would take one step in the process and one standard regarding that one step, and not only have it on a QC process chart such as we just saw, but they would have that instruction displayed prominently at that point in the machinery where it was important to do that step. And the one that I remember them talking about was a maintenance process, and it had to do with lubricating the equipment. And there was a sign at one particular part that said, when lubricating this spot, hold the oil, the lubrication instrument in this way, and it had a picture of a hand in a certain way, and then it said, because that'll help you to reach a spot back there that's hard to get to. Not only that, it had on the floor footprints painted, because they had found through their study that that's where you have to stand when you're holding the lubrication instrument this way in order to get to that spot back there. It's that kind of detail on the best way to do things. And so at least even in the deployment flowchart, you can incorporate some of the explanation about why certain ways are important when it's important to give that kind of detail. On the bottom of page 611 is another variation on the deployment flowchart. Time again goes downward, but the boxes are used to explain what, who, and how, and then the column on the right is just why. There's no sure way to do a deployment flowchart. Find whatever way helps you explain the processes in the way your processes need to be explained. There's yet another variation on the deployment flowchart in the team handbook, although unfortunately it's one that I like least given what I've learned about deployment flowcharts. I want to talk, before we finish up on standardization, I want to talk a little bit about applying the concept of standardization to the 7-step method. I want to try to link some of these concepts. And here I want to talk about what happens before you even start the 7-step method. So before the project, before you've started the 7-step method, my strong recommendation is that you standardize. Don't start what we call improving the process through the 7-step method. Don't even start the improvement effort until you've standardized what you've got. That is, if you've got different operators doing this process in different ways and different shifts doing this process in different ways, then how are you going to improve it? Which of those different ways are you going to improve? And when you're trying to gather data on how well this process works, you're going to be gathering data from one method of doing it and another method of doing it and pretending that that's all one data. When in fact it's not all one data, it's different data because the processes are different depending on who's at the switch when it's done. So I would recommend the work that's involved in standardizing a process, that be done first. When that's done, when you've got a single standardized process with built-in methods for monitoring and adjusting the process, then you'll have a clearer idea of what improvements need to be made. You'll discover that some of the problems that you would have started trying to solve have disappeared simply because it's now standardized. And it'll become clear where the gaps are. You may discover new gaps that were hidden by the unstandardized process. So I strongly urge that standardization be the starting point. And the nice thing about it, if you're a new company starting out, it's relatively easy to teach standardization and to understand standardization. It's relatively easy to teach how to do a deployment flowchart and to have people start constructing deployment flowcharts, for instance, on a process. They don't have to learn sophisticated statistical tools. Those will need to be learned, but it buys you a little time. You can start making some real improvements in the system by standardizing before you go through improvements with a capital I that you'll get from the 7-step method. Sort of getting ready for improvements, but improvements will come simply by standardizing. I strongly recommend that. Let me give you another tip for doing deployment flowcharts. Use Post-its. I have found Post-its to be an invaluable planning tool. I use Post-its. Let's see, I've done workshops with Minnesota mining manufacturing personnel. In fact, I had a bunch of them from the Post-it department. They informed me that Post-its are technically called Post-it brand repositionable notes. That's a product title not developed by a poet, I'll tell you that. I use Post-its to at the top of the columns to say who the key players are, because I may miss a key player when I start out, or I may have them in a different order than I want them at the end. I use Post-its for each of the steps going downwards. The last thing I do when I'm doing a deployment flowchart is to draw the arrow between the Post-its. It's an invaluable way. It doesn't. Otherwise, if you use a magic marker on a easel pad, you're going to end up scratching things off or tearing the pad off and starting all over again. Post-its allow you a lot of flexibility as you're trying to decide how this is. The other thing is when you're getting a group of people to describe the best method for doing this process that you're trying to standardize, it allows people to get up and move the Post-its around or add Post-its if they think there are other steps or that things ought to be done in a different sequence. And if people keep moving it from here to here and somebody else comes up and moves it from there to there, you say, we got to talk about this, don't we? We want to decide which sequence this goes in. Sort of the battle of the Post-its. I had one person describe the process of developing a flowchart using Post-its as a game of strip Post-its. So that's my little handy hint for how to do deployment flowcharts using Post-its. And that ought to happen, as we're showing in this graphic on the relationship between standardization and 7-step method. That kind of work should happen before you start the 7 steps. And then look at step 2 when you're analyzing the current situation. One of the points of comparison is to compare, when you're in step 2, the way the work is actually being done. This is part of the analysis of the current situation. What's the contrast between the way the work is currently being done and the way we described it in our QC process chart? Are we deviating from that? So we can find out immediately whether the improvement that's necessary is either to change our standardized process and develop a new QC process chart, or to make sure that we do it the way that has been agreed upon as the standardized way of doing it. Step 3 is cause analysis, and you can use the QC process chart to identify where things are going wrong. You ought to be able to have, in step 2, narrowed down where things are going wrong, and that may tell you where to start looking for causes and lead you to what changes need to be made, not only in the process, but then obviously in the standardized process as shown on the QC process chart. When you're doing step 4, the solutions, the best way to identify the new method that you're trying out in the solution step is to put it in a QC process chart. And then in step 5, in the results, you contrast how you did it versus the way you said you were going to do it using the QC process chart in step 4. QC process chart becomes the focus of your study. So in step 4, you say, here's our new method, described in a QC process chart. And we implement it, and then we look at the solutions. And remember I said before, you not only want to see, did you get the results you wanted, but did you get the results you wanted by using the plan that you said you were going to use? So 2 questions to ask. Did we improve it? Does the data show us that we improved it? And secondly, did we use our QC process chart plan? If we didn't, where did we deviate? And then how do we know we got those improvements? Or how do we know how we got those improvements? And then finally, step 6 is the step called standardization. Step 6 is where you do what we've been talking about. It's where you finalize the new standard method using this thing that we call the QC process chart. let me make one other comment with regard to the QC process chart, and that's the form that you have in your notes on page 6-9, and if you want to show the graphic again, it's I'm sorry, I don't know what the number of the graphic is, but it's the QC process chart format. This is set up mostly for use in manufacturing processes. The manufacturing processes more likely will need some of those columns and others won't. But keep in mind, if you're doing this with an administrative process, the headings across the top, you have to have some flow chart showing the various sequence of steps in doing the work, and a deployment flow chart is very useful in administrative processes as well. And then the checking of the work is still important. What are the key indicators and what are you going to look for and monitor? And then the various responses to the work. As long as you have some information in your QC process chart that shows how are you going to monitor the work and then how are you going to respond to that work, then you can adapt the QC process chart for your purposes when you're working with an administrative process. You may not need the same kind of detail. It may be a little simpler, but make sure you don't lose sight of the fact that you have to show in your standardized process how you both monitor the work and how you adjust what's going on based on what you discover when you're monitoring the work. That's the completion of the presentation that I was going to make on standardization, and I'm hoping that if you have any questions or anything that's not exactly clear about that, you'll use take advantage of the opportunity to ask questions and to call in your questions. We've still only got about 25 minutes or so for you to call your questions in, so that we can treat them during the last 45 minutes of this program. Section 7. What I plan to do, by the way, is go through Section 7 in a minute. We'll take a short break, and it's simply a summary going through the ingredients of improvement. We'll take a short break, giving you a chance to call in your questions, and then I have a few questions that have already come in that I'll talk about, and then we'll take what we described as a 15-minute break before the full question and answer session. But let's take a short pause right now. Okay, we're back for the final stretch of the presentation part, and this won't take long, but as I said, I will spend some time answering some of the questions that came in already. As a summary, I want to return to the 5 ingredients of true improvement. And the first ingredient, you'll recall, is the proposed change is rooted in a deep awareness of your customers and their concerns and how they apply what you supply. So I want to emphasize the fact that improvement starts with the customers. And if you stray very far away from your customers and their needs, then you're likely to go down the path of the illusion of progress. And let me explain something. I had planned to explain this, but we have a few extra minutes, and so I want to elaborate a little bit on the customer's view of quality. Dr. Kano, one of the teachers with the Japanese Union of Science and Engineering, which is sort of the heart of the Japanese quality movement. It's where a lot of the thinking and training goes, and they're the ones that sponsor, for instance, the Deming Prize in Japan. Dr. Kano describes 3 kinds of characteristics of quality, 3 dimensions of quality from the customer's point of view. The first dimension of quality Dr. Kano talks about is the basic characteristics of quality. These are the things which don't excite you when they're present, but when they're not present, they make you angry. For instance, when you go out in the morning to start your car and it starts, you don't say, "Hey, my car started." You don't get excited about that. But you do get angry when your car won't start. So there's certain expectations that are so basic that the products must have those characteristics. Those are the basic expectations. And again, they don't create satisfaction, they just avoid anger. There's a second dimension of quality The second dimension of quality is the satisfiers. And the more these characteristics are present, the more satisfied the customer is. If I get 12 miles to a gallon of gas in my car, I'm not terribly satisfied, but I'm more satisfied than I would have been if I got 8 miles to a gallon. If I get 15 miles to a gallon, I'm more satisfied. If I get 20 or 25 or 30, I get more and more satisfied. So some improvements can be made in terms of building greater and greater satisfaction on a fairly commonly accepted characteristic. Sometimes we do things, we try to make things smaller, because the smaller it is, the better it is for the customers. If you look at a television set, the thinner it is, the less space it takes away from the wall that it's against. That's a characteristic that's similar to a satisfier. The clearer the picture on a television set and so forth. Those are all satisfier characteristics, the sort of middle dimension of characteristics from a customer's point of view. The third dimension of quality that Dr. Kato talks about are the delighters. Those are the unexpected surprises. And these are the things that are easier to design and understand when you're very close to the customers, when you understand how customers use your products. An example that I just heard of yesterday is I think it's Ford now has elastic straps in its trunk for holding grocery bags so they won't tip over. That's an example of something that somebody thought of because they said, hey, it would be nice. Wouldn't this be a nice thing for our customers to put in? Now, it doesn't do any good to have the delighters if you haven't taken care of the basics. Your customers won't give a rat's tush about elastic straps in your trunk if it's in a car that won't start in the morning. So it's important to take care of the basics first and to take care of a lot of the satisfiers before you start chasing after the delighters. But improvements ought to be based on what will please our customers, what will assure them of the basics, what will more and more increase the satisfier characteristics, and what are the other delights that we can build into our product. It's the delighters, by the way, if the others are taken care of, it's the delighters that will make your customers boastful. They'll brag about your product. You won't have to advertise it. People will go out of their way to buy your product. That's characteristic one, that the changes and the improvements ought to be rooted in an understanding and awareness of your customers and their needs. The second ingredient of improvement is that the proposed changes are important to the business and are acknowledged as important by the customers. They're acknowledged as something of value. So again, avoid those projects that are simply for the internal convenience of the people in your organization. Make sure that the improvements that you try to introduce will have some relevance or importance to the business as a whole and its customers. And let me make one other comment about this one. A lot of times, improvements are justified because they're seen as cutting costs, and therefore if we cut costs, we can be of more benefit to our customers. I'm still leery of those. A lot of times costs are cut to the detriment of the customers. We try to cut a corner here, we try to cut a corner there. It may look okay to the customers, but it won't last as long, for instance. So it's the dimension that's important here is long-term value to the customers that I think is important. It's not enough for it to be good for the business. I would not justify it simply in terms of cutting costs. It ought to maintain or improve the value to the customer and cut costs. Dr. Deming talks about his chain reaction. You can read this in his book, Out of the Crisis. The chain reaction describes a whole strategy of quality of competition that's based on quality. You start out improving the quality of your goods and services, and the quality of the processes by which you deliver goods and services to your customer. That will lead to increased productivity and reduced costs and greater market share and so forth. But you don't do it by bypassing the improvement of quality step. You have to go through that. The third ingredient, the approach to change must be disciplined, logical, data-based, and address the deep causes of whatever it is that's in need of remedy. We've talked a lot about that today. The scientific approach. The fourth ingredient, the change has to be supported by subject matter expertise, but not just a subject matter expertise. It ought to be supported by an understanding of the system, understanding how change in one operation affects other interdependent processes in the system. We gave some examples of that. Finally, the change and its good intentions, the deeper knowledge that you've gained from this study, and the improved methods that you've learned have to be translated into a clear graphic picture of a new standardized operational procedure. And a QC process chart, I believe, is a very powerful instrument for displaying the new standardized process. Now, we're going to be taking a break pretty soon, and this is an opportunity for you to let us know what your questions are, what's on your mind. If you want me to elaborate on some point that I've made that you need some more explanation of, I'd be happy to do that. So we have about 15 minutes before we return for our questions. Let's do that right now. And I said I was going to get to some questions. I'll get to those right away after we return from this break. Thank you.